Hi there! Welcome to a new physics lesson filled with adventure and discovery. Today our topic is resistors in parallel. Last time we took a look at resistors in series and what a series circuit is. Today we're looking at resistors in parallel and how they're slightly different from resistors in series. So let's jump into it. This schematic diagram I have here is a good example of resistors in parallel with this circuit. And notice they each have their own pathway. They're not all in the same line. This is a good example of series in parallel. And so notice, each resistor is parallel, and it has the same potential drop or same voltage across each of them. The current's going to be different, but the voltage is going to be the same. And so the sum of the currents will add up to the total current in this resistor. That's in contrast to in a series circuit, the current is the same, but the voltage is different across each 1 over R1 plus 1 over R2 plus 1 over R3. So if I take the 1 over 5 plus 1 over 3 plus 1 over 6, I'll get a number. Take the inverse, or -1 or 1 over that number, I would get 1.4 total resistance in my circuit. Okay, so notice the total resistance in this circuit is very small compared to the individual resistances. And so just as a reminder for resistors in series or in parallel, just to compare the two, the current, okay, is going to be the same throughout a series circuit. However, they're going to be split or divided in a parallel circuit. And then vice versa for voltage. Voltage adds up to the battery voltage in series, potential difference. And then for parallel, the voltages are the same for each resistor. And then for resistance, notice it's each of the resistance can add up to a sum of individual resistance. However, in parallel, it's a little bit different because we use a reciprocal sum. Okay, so that's kind of the summary of circuits, series versus parallel. So there's one last thing I wanted to show you before we leave parallel. And now that we've talked about series and parallel circuits and resistors, I just wanted to show you something real quick about something practical that has to deal with these two different types of circuits. So in this FET simulation, notice that I have one circuit in series. I have 3 light bulbs that are all connected in series, they're all in one line. In the middle here, I have 3 light bulbs that are connected in parallel. They each have their own pathway that leads to the battery. And then lastly, I have 3 resistors in parallel, just to show you something there as well. But I want you to notice that first of all, that even though there's 3 light bulbs here, same battery, 3 light bulbs here, notice which light bulb is brighter. By having light bulbs in parallel, because we have the same amount of current running through this system, or actually we don't have the same amount of current, but we have the same amount of voltage through this system, the lights will be very much brighter, noticeably brighter in a circuit in parallel. If I have a circuit in series, since the current is the same, voltage is not the same, my light bulbs will not be as bright. Also, if I disconnect one of the light bulbs, let's say I delete this light bulb, notice what happens. It totally destroys my circuit. None of the light bulbs exist, or none of the light bulbs are turned on. And so for series circuits, sometimes we have a hard time because, like for example, Christmas lights, if one of the lights goes out, then all the rest of the light bulbs are out as well. However, for a parallel circuit, if I delete one of my light bulbs here, notice the other 2 remain unaffected because they have their own pathway, they have their own circuit. And so that's kind of the big difference between parallel and circuit, the resistors in parallel and resistors in series. And then one last thing, down here, notice I have 3 resistors. Just by looking at it, which resistor has the most resistance? Just by looking at the way these electrons are flowing through this system. Hopefully, you could tell that this one right here in the middle, notice it's 120 ohms almost, is the electrons are moving the slowest. Followed by this guy, 51 ohms, and this one by 10 ohms. And so notice that because there are different amount of resistance, they're all in parallel. The current, however, is going to be different. The rate at which these electrons are moving through the circuit are going to be a little bit different depending upon the resistance of these resistors. However, parallel circuits do seem the most effective when we're stringing lights together, or when we have certain appliances string together, or your outlets in your house, for example, should be in parallel rather than series, just in case one of them goes out, as well as the even distribution of the voltage. All right, so that's the comparison between parallel and series circuits. Thank you so much for joining us, and we'll see you next time.